In this lecture, we'll learn about the pipe operator, right? So if you remember in one of the previous lectures, that is the first lecture on dplyr verbs, we had looked at the solution for computing the average order value in two ways, right? So first we went through each step and the resulting data set was stored in a new data frame, right? So we ended up with 6 different data frames starting from ecom 1 to ecom 6, and then we looked at another solution, right? So in this case we did not create any intermediate data frames, but we passed the result or the data frame from one step to the next step using the pipe operator, right? So the symbol that you see there with the percentage and the greater sign, it is called a pipe operator, and using that we passed on the result of one step to the next step, right? So we took the ecom data set, passed it to the filter function, we filtered out all the purchases, then we passed that data frame to the select function and we selected device and order value, and then we passed that result to the group by function. We grouped the data set by the device column. Then we use the summarize underscore all function to calculate the total order value and the total number of orders. Then that resulting data set was passed to the mutate function, and we created a new column called AOV using the revenue and orders column. And again that data set was finally passed to the select function to select the device and AOV columns. Now if you compare this with the other solution, we ended up creating intermediate data frames or data sets, but in this case we don't do that, right? Because we are using the pipe operator to pass on the result from one step to the next step. So in this lecture we are going to learn about the pipe. We'll also learn about two additional pipe operators. I'll come to them in just a bit, but the agenda for the lecture is we'll understand what pipes are, why we need to use pipes, what are the different types of pipes, we just saw one, and how we can combine operations with pipes. And we'll explore the pipe operators using simple case studies, right? Now here's a bit of an introduction about the pipe operators. They basically come from the magrittr package, and we have explained how pipes help us read more readable code, right? So I'll not go through this now. We'll go through some examples first, and then while summarizing this lecture I'll come back to these points, because then we'll be able to better understand them after going through the examples. Now if you are using the tidyverse package, then magrittr package will be automatically loaded and we'll be able to use the pipe operators. Now there are three different types of pipes, right? So this is known as pipe operator, and it will pipe a value forward into an expression or function call, like how we saw in the example. The output from one step or one function is passed on to the next function call. The second one is called as assignment operator, okay, and we'll explain what this does with an example. And the third type of pipe operator is called the exposition operator. This will be used when you want to expose a particular column or two columns or multiple columns from a data frame, right? So we'll use all these three different types of pipe operator in our examples, and then you will get a good idea of what each of these operators do, right? Now we'll use 4 packages in our example, of course including the magrittr package. We'll also use readapp so that we can read in some data set. We'll use dplyr so that we'll select some columns from our data set, and we'll use a package called stringa, which is used for manipulating strings, and we'll use that in one of our examples, right? So let us load these packages using the library function. First one is magrittr, and then we'll also load the readr package, then follow it up with the dplyr, and finally the stringr package. Now we are going to use the same data set that we have been using through this course, which is the ecom data set, a dummy data set about a imaginary e-commerce website, right? But we'll not be using all the columns from the data set. We'll only use the referrer column, the number of pages visited on the site column, the time spent on the website column, which is duration, and finally whether the visit resulted in a purchase or not, right? So let us read in this data set, right? So if you are not clear about this code that we are writing here, please refer to the import data into R course, because that is where we have learned or explored how to read data into R, right? So here is a quick view of the, sorry, let me read this in. Okay, so here you can see the data set. It has 1000 rows and 4 columns. The columns are referrer, n_pages, duration, and purchase. Okay, so we'll use this to go through some of our examples. The data dictionary is also there, so that you can come back and refer to the description of these variables or columns. Right now, since the data set has approximately 1000 rows, it might clog our console when we use the whole data set in our example. So what we'll do is we'll create a mini data set which has about 10 rows of data from the ecom data set, right? So create a sample data set. We'll call it ecom_mini, and we'll use the sample_n function from dplyr, and we'll sample 10 rows of data. Okay, so this will ensure that our console will not get clogged with the data when we go through the examples. Okay, the first example, right? So we'll start with a very simple example, right, which is looking at the first few observations of our data set using the head function, right? So let us go here and try this out. I'm going to use the head function. Okay, I'm going to use the ecom data set because this function will return only a few rows, right? So here you can see the first 10 rows of the ecom data set. Now if I write this using pipe, how will it be? So the description of this step would be, take the ecom data set and then display the first 10 rows of data using the head function, right? So if I write it in that way, I say take the ecom data set and then pass it on to the head function to display the first 10 rows of data, right? So you can see that the output from both these lines of code is the same, right? So we have taken the head ecom data set, and using the head function we are trying to display the first 10 rows of data, right? So the second line, it is easier to say this because you written it in the same way you would describe it, right? So take the ecom data set, pass it on to the head function, and display the first 10 rows of data. Now this is still very simple, right? It doesn't involve many steps, and we are not creating any intermediate data frames or R objects, and there are no nested function calls here, right? But we'll come to that, and then you will be able to see how using pipes makes your code more readable, right? So we'll now move on to a slightly different example. Okay, now here we want to compute the square root of the n_pages column in the ecom_mini data set, right? So now we'll use the ecom_mini because this function will clog our console because it has 1000 rows. The ecom data set has 1000 rows, so it will clog our console. So what we'll do is we'll use the ecom underscore mini data set, and from that data set we want to take the n underscore pages column and we want to compute the square root, right? So if we do it in the regular way, it would be like this, right? So we will use ecom underscore mini, then we use the $sign to access the n underscore pages column, right? So this is your data, and this will pass it on to the square root function, right? So now you see the square root of the n underscore pages column in ecom underscore mini data set, right? And if I want to store this, I can just store it in a variable called y, right? Now y has the square root of the n underscore pages column from the ecom underscore mini data set. Now if we do this with pipe, how can we achieve this, right? There are a couple of different ways. So we'll first look at the exposition operator here, right? Because we want to use the n underscore pages column, we can use the exposition operator, right? Now look at the output from this, right? It is displaying the n underscore pages column as a vector, and this is same as ecom underscore mini $n underscore pages, right? The output from both of these is the same, right? Now here we pass this into the square root function, right? This was passed into the square root function here. Now what we'll do is we'll use the exposition operator, right, to expose the n underscore pages column, okay, and that will pass it into the square root function. Take a look at this, right? This is the same as this output, square root of ecom underscore mini $n underscore pages. You can write it like this, right? Now if I describe this, let me put the comment here using pipe, okay, and I'll just bring this up a bit so that it is visible on the screen, right? So if I describe this is how it will be. Take the ecom underscore mini data set, expose the n underscore pages column and pass it on to the square root function, right? And the pipe operators are also different, right? So you're using the exposition pipe operator here to expose the n underscore pages column or to return the n underscore pages column, and you use the pipe operator to pipe that value, right, the n underscore pages column, into the square root function, right? It will take this, whatever is returned by this, which is this vector here, right? It will take this vector and pass it on to the square root function, right? So here you can see that we have one function into which we have passed the vector, and now we have split it into 3 lines of code. Take the data set, expose or return a particular column as a vector, and then pass that vector into the square root function, okay? Now if I want to save this into a particular variable, I want to store it or save it, then I can use the reverse assignment operator. This is take the ecom underscore mini data set, return the n underscore pages column as a vector, pass it on to the square root function, and the final result store it in y, right? So you can go here and check the value of y, you can see the square root result. Right, now I can do one more way, right? I can store the output from the first step, which is ecom_mini return the n_pages column, store it in y. Right, so now if I type y, I'll see the n_pages column as a vector. Now I want to compute the square root of the values in this vector and save it in y. So one way to do that would be y square root of y, right? Take the square root of y and save it in y. Okay, now let us try this using the assignment operator, right? So I'm going to change the value of y again. Now it is not the square root of n_pages column, it is just the value in the n_pages column. Now instead of this, what we'll do is we'll say compute, right? We'll say compute the square root of y and save it in y itself. Okay, so now if you see here, the value of y is what is found in the n_pages column, but once I run this code, the value of y will be the square root of the n_pages column, right? So we have taken a quick look at all the three operators. The exposition operator will expose or return a column in the data set. The pipe operator will take the output of the previous step, which is this one, right? Whatever is the result of that step, and pass it on to the next function call, right? So it took whatever was the result from this step, which was the n_pages column as a vector, and it passed it on to the square root function. Now this operator, what it did was it computed the square root of the values in the y vector and reassigned it to y, right? So the y vector, initially it had these values, right? The values in the n_pages column. Now this operator, which is the assignment operator, it took all these values, okay? It computed the square root and it reassigned these values in y. So when you type y now, you'll see the square root of these values which were there in y earlier. Okay, so it might still look confusing for you, but as we go through more examples, you will get a feel of how these pipe operators work. Right, now let us go to the next example here. Right, so here's a visual presentation of what we did. Right, so we had this ecom_mini data set. Using the exposition operator, we exposed or returned the pages n_pages column as a vector, and then using the pipe operator, we passed the n_pages column, which was returned as a vector, to the square root function to compute the square root of n_pages. Okay, so the first one returns or exposes a column, and the second one passes the output from the previous step to the function call in the next step. Okay, so here is again the code that we just tried out. Now let us move to a slightly more complex example. Okay, here what we are going to do is we will calculate the correlation. Okay, we'll calculate the correlation between number of pages, right? There's a number of pages browsed on the site and the time spent on the site. So these information are represented by the n_pages column and the duration column. Right? So first we'll look at this visually. Right? So we have n_pages and duration and purchase columns here. And first we'll use a function called subset to filter out all purchases, right? So we'll look at all the rows where purchase column has the value true, right? These are visits which resulted in a conversion, right? So now if you look at the second data set, it has only those rows where the purchase column has the value true. Okay, then we'll use the exposition operator to expose the n_ pages and the duration column, right? And that we will pass it on to the core function, right? The core function computes the correlation in R, so we'll use that to compute the correlation between the number of pages browsed and the time spent on the site, right? So first we'll see how we can do it in a regular way without using the pipes, how we can achieve this result, right? So first step, let me clean up the screen a bit for you. Right, so we'll take a look at the correlation example. Right, so first we want to filter out all the purchases, right? All those visits which resulted in a purchase. So we can achieve this using the subset function, right? And this output will save it in a data frame called ecom1. Okay, and then from the ecom1 data set, we'll calculate the correlation between n_ pages and duration. Right, so here is the correlation, right? It is 0.42 or 43. Now let us try to arrive at this result using the pipe operators, right? So how do you define what we just did, right? So we computed the correlation between the number of pages browsed on the site and the time spent on the site, but only for those visits which resulted in the purchase, right? So this is how we do it, right? So first we take the ecom data set, right? So we pass it on to the subset function, and then we filter out all those rows or visits which resulted in the purchase. So since purchase is a logical value, if you want to filter for true, you just specify the name of the column, and if you want to filter out for false, you will use the not operator before the column, right? So since we are filtering out for true values in purchase column, we'll just specify the name of the column, right? And from this, once you have filtered out for all those visits which resulted in a conversion, we want to expose two columns, right, which are basically n_ pages and duration, and these two columns we want to pass it on to the core function, right? So you take the ecom data set, you filter out all the visits that resulted in a conversion using the subset function, and then you pass on these two columns which are n_ pages and duration using the exposition operator to the core function, right? Let me run this, right? You can see the same result, right? So it saved us from creating a intermediate data frame or R object, which was ecom1 in the previous case, and we did not have to mention the name of the data set when we were specifying these two column names, right? Here we had to specify ecom $1 n_ pages, ecom $1 duration. Here we didn't do that, right? Using the exposition operator, we were able to pass on these two columns to the core function without specifying the name of the data set and without creating an intermediate data frame which was ecom1. Now with small data sets, it's fine if you still create an intermediate data set, but when you are dealing with very large data sets, if you end up creating multiple intermediate data sets, then it will take up a lot of space, and your R session will slow down, right? So it is always good to avoid creating intermediate data frames or R objects unless you plan to use them for some other computation, right? So again, in this example, we have used two operators. One is the pipe operator to pipe the ecom data set into the subset function, and then we use the exposition operator to expose the columns of the data frame to the core function, right? Now the above function can also be written using the filter function, right? So if you're not aware of the subset function, you might get a little confused here, but if you looked at the previous lecture, that's the first lecture where we explored the dplyr verbs, then this code will make sense to you, right? Take the e-commerce data set, filter out all the visits which resulted in the purchase, and then pass on the n underscore pages and duration columns to the core function, right? So this is another way of arriving at the same result. Okay, now we look at some more examples. This was on correlation. Now we'll look at another example which will include visualization. Okay, so here basically we are taking the referrer column and we are looking at the traffic driven by different referrers, right? And we are doing that by creating a bar plot. Now look at this code here, right? So we have the bar plot function, then we have the table function, then we have the subset function, and we are also using the dollar operator to refer to the referrer column, right? So we'll first write this function and see how it comes. So we'll first create that plot using the code that we see on the slide, right? And that would be first v subset. Let me just comment this out, right? So first we are using the subset function to filter out all the visits which resulted in the conversion, right? So this we do using the subset function, right? And here is the output. Now we want to use the referrer column, right? So next step is to use the referrer column or refer to the referrer column using the dollar operator. Right? So I'm just kind of going to clog our console, so let me clean it up. Okay, so we have filtered out for all those visits which resulted in a conversion, and then we use the referrer operator because we use the referrer column because we are going to plot it. Now when you are going to use the bar plot, you cannot just input this value. First we have to create a count for each of the referrers, right? So this will be passed into the table function, right? Whatever we saw in the previous step, we'll pass it to the table function, right? So now you have a count of the different referrers, how many visits came from each of these referrers. Okay, now the next step is to pass this table to the bar plot function. Okay, so use the bar plot function and we will pass on the result from the table function to the bar plot function. Right, so here you can see the plot. Right, now we'll recreate the same plot, but this time we'll write our code using the pipe operators, right? Using pipe, this is how we are going to write our code. Now before we do that, let us take a quick look at the steps that we follow when we are doing this. right? So we have this data here. We have referrer, device, and purchase. What we want to do is we want to filter out all the visits that resulted in purchase. Okay, and then we'll take that, we will extract the referrer column, right? From that table we'll extract the referrer column, then you pass it on to the table function. When you pass it to the table function will create the counts for each of those referrer types, right? And then you'll pass on the referrer name and the count to the bar plot function to get your bar plot, right? So this first step where we filter for the purchases or visits that converted or resulted in a conversion. The second step, we extract the referrer column. The third step, we pass the referrer column extracted from the data set to the table function. The fourth step, we take the counts from the table function and pass it on to the bar plot function. So let us see how this can be written using the pipe, right? So we take the ecom data set and we pass it on to the subset function to filter out all those visits which resulted in a conversion. And then we take the filtered data set and pass it on to the extract function to extract the referrer column, which is then passed on to the table function to get the counts for each of the referrer, and that output is passed to the bar plot function, right? So let us see how we can do this here. So I take the ecom data set, right? I pass it to the subset function to filter out all the visits that resulted in a conversion, which is then passed on to the extract function to extract the referrer column, right? The output is then passed to the table function, which will calculate the counts for each of the referrer types, and those counts are passed on to the bar plot function. So let me remove this plot so you can see how this step also creates the same plot, right? And this, you can see, it goes nicely with the narrative, right? It's very intuitive. Now just for the sake of a better understanding, let us look at the output from each of these steps, right? So here ecom data set is passed to the subset function to filter out all the purchases, right? You can see them here, right? The purchase column only has 2 values. Now this data set is then passed on to the extract function to extract the referrers, right? So this is again it has the referrers from the previous step where we filtered out for all those visits that resulted in a conversion. Now the output from this, we'll pass it on to the table function, right? So now you can see the count for each of the referrer types. Now this data is passed on to the bar plot function to create the bar plot for the frequency of these different referrer types, right? So you can see how you can sort of explain each step when you are using these pipe operators. Here you have to figure out how the whole thing is working out. Okay, here we are subsetting, then we are using the referrer column, then it is being passed to the table function, and that output is passed to the bar plot function. Here it is easier because you start from here and end up with bar plot, right? Now we look at some more examples as well, right? So here's one on regression. So regression in R, it is linear regression is done using the LM function, and we are specifying the independent variable, which is n underscore pages, and the dependent variable, which is duration. So I'm basically regressing duration on n underscore pages using the data e-commerce, and then we pass that to the summary function to get the regression results. Right, so this can be done again using the pipe like this. Take the e-commerce data set, and then you expose the duration and n underscore pages column to the lm function, and that output is passed on to the summary function. Now let us try this out. Right, so here is a regression example. Right, so first we'll see the output from this one. Right, duration based on n underscore pages. The data to be used is ecom. Right, and then I can pass this on to the summary function to get the summary of the regression. Right, now if I use pipe, I'll first use the ecom data set. I'll expose the duration and n underscore pages columns to the lm function, and that output, which is this output, right, so this whole output that you see here, or whatever the function returns, is passed on to the summary function. Right, so you get the same result. First let us create the email ID. Okay, email is jovialcan@anymail.com. Right, so you can see the email here. Now we'll use the pipe operators to extract the name Jovial and convert it into uppercase. So I take the email ID, I pass it on to string underscore split function, and I will ask it to look for the pattern at. Right, so search for this pattern and split the email ID. So now it has split it into two parts, right, jovialcan and anymail.com. Now I don't need the second part, which is anymail.com. I just need the first part, which is jovialcan. So now I'll pass this output into the extract2 function. Okay, extract2 will extract the first part. Right, if you see, this is a list. Right, so what you're seeing here is a list. This is not a vector, and you can use extract2, the function extract2, to extract elements from a list. Right, so first you have to extract this part and then extract the first element. Right, so we'll extract from the list. This is what you will see. Right, so now we have a vector. Now this was a list. Right, this was a list. So once we use the extract2 function and extracted the first element of the list, now we have a vector. Now from this vector, it has two elements. Right, the length of this vector is 2, jovialcan and anymail.com. Again, I don't want the part anymail.com, I just want the first part, which is jovialcan. So I'll use the extract function and pull out the first element from the vector. Right, so we first split the email ID using the pattern at. That gave us a list. From that list, we extracted the first element of the list using the function extract2. That gave us a vector of length 2, which is, the first part was jovialcan and the second part was anymail.com. Again, from that we extracted the first part of the vector, which was jovialcan, and we use the extract function for extracting it from the vector. Now from here I will use the string underscore sub function, and I'll say extract the first 6 letters. So starting from the first letter up to the 6th letter, you extract them. So this should return jovial. right? And this will be passed on to the function string underscore to underscore upper. Right, now you can see jovial is in capital letters, right? So you might not know all of these functions, but I just wanted to go through this case so that you can use the pipe operator to write the code in the same way as you think, and you can also avoid creating intermediate R objects, right? And it's also nice to read step by step. What we are doing in each step is pretty much intuitive here, right? So that's good. So we have gone through a lot of examples now to understand uh, these pipe operators, right? And what we'll do is look at some data extraction functions for data extraction as well, right? So we looked at extract to and extract here, right, in the previous example. Now we'll take a look at what each of those does, right? So let us look at one more example, right? So this is about string manipulation, and what we are doing is we have an email ID. It's a dummy email ID called jovialcan@anymail.com. I don't know if anyone uses it, but I'm assuming that nobody uses it. So this email ID, what we want to do is we want to extract the name jovial and convert it into uppercase. Okay, and to do that we have this long line of code you see, right? So there's a string underscore split function, and then there's a string underscore sub function, and there's a string underscore upper function. Okay, and finally it does return the name jovial in uppercase. Now we will do the same using pipe operators, and we'll see that the code will be easier to read, right? So the steps to do this is that you'll first split the email ID at the point at, right? So that will separate the name, that is username, from the domain @anymail.com, and then you will take the username and extract the first 6 letters, which are jovial. Okay, and that is done using the string underscore sub function. Splitting the email ID at the point at is done using the string underscore split function, and splitting and then extracting the first 6 letters is done using the string underscore sub function, and converting it into uppercase is done using the string underscore to underscore upper function, right? So that is the step, and we'll now do that using pipe operator. So the 3 functions for data extraction, one is extract, one is extract to, and the third one is use series. Data extraction. So for example, to extract the n underscore pages column, we'll use the square brackets, right? And then we are specifying the name of the column within the single quotes, right? So you can do the same using the extract function here. Extract from the ecom underscore mini data set the n underscore pages column, right? Now if you want to specify the position of the column instead of the name, then this is how we would do it, right? Ecom underscore mini and return the second column, right? You can do the same with extract as well, right? You extract the second column from ecom underscore mini. Now if you want the column to be returned as a vector, then you will use the dollar symbol, right? Here you can use underscore series, right? So now if you look at this part of the code, ecom underscore mini dollar n underscore pages, right? So now n underscore pages column is returned as a vector. If you want to do that using magrittr, you can use com underscore mini and then the name of the column. Now how about list, right? So let us say, so far we have looked at how we can extract columns from a data frame or a table. Now what if we have a list, right? So let us convert ecom underscore mini into ecom underscore list using as dot list ecom underscore mini, right? So if you look at ecom underscore list now, right? So here each of the column has been converted to an element of the list. Okay, so let's come back. Now to extract the element of a list, we can do it in two ways, right? You can use the double square brackets, right? So we have com underscore list and then we use the double square brackets to extract the n underscore pages from that list. Or you can do is you can use the dollar operator as well. Right, now if we do that using magrittr, then we'll use the extract to function. So extract to and ecom underscore list name of the element, right? And you can also use underscore series, and in this case you don't even have to enclose the name of the column in single or double quotes, right? Fine. So if you want to extract list element by position, you can do that as well. So in this case we can have ecom underscore list, extract the first element of the list, right? And using extract to, we do the same, ecom underscore list 1, extract the first element of list. Extract to, right? So you can see the output is same in both these cases, right? So I'm just showing you the alternatives that are available in the magrittr package for working with extracting columns from data frames or extracting elements from a list, right? Again, here you can see how we did extract elements as a vector, right? And magrittr also has these arithmetic operations which are add, subtract, multiply by, divide by, and the modulus function, the raised to power function. So you can go through this, right? So in the slides and in the learning management system, we have shown several examples of how you can use these functions from magrittr, and there are certain logical operators as well, right? So you can go through the examples and you will know how to use them, right? So you can see pipes allow us to clearly express a sequence of multiple operations by structuring operations from left to right, right? So for example, here if we go to this example, here we go from right to left, right? So we start from here and then we went to the table function and the bar plot, but here we start from here. So we start from ecom, then go to subset, then go to the extract function, the table function, and the bar plot function, right? So you are structuring your operations from left to right instead of right to left. You are avoiding nested function calls, right? One function inside the other. These are called nested function calls. When one function is called inside another function, you are avoiding intermediate steps, like in this case, right? You can avoid intermediate steps and creating intermediate data frames or objects. You avoid overwriting of original data, which we saw in the case of square root, right? You don't have to override your original data, and you minimize creation of local variables. So you don't end up creating variables just to store the output or result from a previous function. Using the pipes, you can just pass on the result from one step to another without creating local variables. And the pipe operators, right? So we saw that the pipe operator is used to pass the result or step from one function to the next function or the next step without creating an intermediate or object. The assignment operator, we used it to assign a value to an object itself. So for example, when we were calculating the square root, we computed the square root of n underscore pages and then assigned it back to y using this assignment operator. And the exposition operator, so we use this in several cases here, right? So we used it to expose the n underscore pages function, and while calculating the correlation, again we expose the n underscore pages and duration column, right? So here in the regression example, again we used it to expose the duration and n underscore pages column, and we pass it on to the lm function, right? So now I think once you have gone through the examples, these definitions will make more sense and will help you understand better. We have given the link to the magrittr website, so it's magrittr.tidyverse.org. You can come here and you can take a look at the documentation, and you can go through the examples, and you can also go through all the examples that we have worked here, right, in this lecture. Now all the scripts and all the data sets are available in the learning management system, and they're also available in the GitHub repository. So you can go through them, you can try these examples, and if you need any clarification or if you need any other help, please feel free to reach out to us, and we'll see how we can help you out. Okay, so thank you for going through this lecture. It is important because in some of the other courses that you will be taking up, we will be using pipe operators. We'll also look at code without pipe, but more or less we'll end up using these operators, and it will be easier for you to understand what is happening if you have a good understanding of these pipe operators. Thank you.